Ladies and gentlemen, hello and welcome, coming to you not quite live from One Take Studios, where today we are talking about graphing functions. Alright, today I'm not talking about any specialized patterns. I'm talking about what can I do to graph any function. Alright, so what we're doing today will work for every function on the planet, which is kind of nice. So I'm going to show you demonstrations of three different types of functions. So this is the first one. This is 2x plus y equals 3. And I would like to graph it. So how would I make that happen? Well, the true and tried method that works for everything on the planet is a delightful XY table. All right, so let's see if we can get some values going for this thing and get it graphed. Well, where do the values come from? People struggle with that. The values come from your brain. I want a graph. I want to know what's happening. Here's my x-axis, so this is x. Here's x-axis. I'd like to know maybe what's happening at 0. Maybe what's happening at 1. Tell you what, maybe I'll go back to -1. All right, so let's start. I'm going to pick -1. Why? Because I want to know what's happening. And maybe I pick 0, and maybe I pick 1. So I want to know what's happening here, here, and here. That seems like a good place to start with that. How do I get these values? Well, I have a delightful equation right here. I have an x value. Why don't I take my x value and plug it in place of x? So instead of 2 times x plus y equals 3, I put in this -1, and I get 2 times -1 plus y equals 3. Now, some of you may know a couple faster ways to do things here and there, but honestly, have some patience. This is not going to be that difficult. What's 2 times -1? I can do that. That's going to be -2 plus y equals 3. I'm trying to find y. I need to get y by itself. How do I undo this -2 that's sitting here? What happens if I add 2 to the left side and I add 2 to the right side? All of a sudden, what happens? These guys drop out. There's my y by itself. Yay me. And 3 plus 2 is 5. What does this mean? When I plug in -1, I get a 5. So that is the first of my pairs, -1, 5. -1, 5, right there. That point is going to be on my graph. That was so much fun. Let's do it again with a 0 this time. So again, taking the x out and replacing it with a number. So 2 times 0 this time plus y equals 3. Oh, I like this one even better. Because what's 2 times 0? 0. And quite frankly, what is 0 plus y? That's just y. Hey, there we go. Y equals 3. So if I plug in 0, I get 3. That y is already by itself. I'm good. 3. Plug in 0, get 3. There's my next point. And I'm going to do one more here, one more. What happens at 1? So I'm going to squeeze this in here. 2 times 1. Instead of 2 times x, 2 times 1 plus y equals 3. 2 times 1 happens to be 2 plus y equals 3. And I'd like to get that y by itself. So I'm going to undo the +2 with a -2 there. -2 on both sides. That's gone, gone. So now I have y equals 3 minus 2 is 1. So there we go. If I plug in a 1, I plug in a 1, I get a 1. That's kind of nice. So 1, 1, right there. What do I see happening? I see a very nice line happening. And if I'm graphing lines, I'm going to do that with a ruler. By the way, if you happen to notice a pattern here at the blocks, from here to here, I'm going down 2 blocks and over 1 block. Down 2 blocks and over 1 block. That isn't an accident. I can keep that pattern going. Down 2 blocks, over 1 block. I like that. That helps me get my ruler nice and straight. And there we go. What is this graph? This graph is actually a representation of every single last ordered pair that works in this equation right here. So I want to have the arrows at both ends to show that this keeps going. And I can pick any point on this line, including the decimals and fractions, and it's going to work in this equation. So a little bit of patience, but guys, that's it. So let's change up some forms and see what different functions might look like. The next one up here I have is y equals x squared. Y equals x squared. So what's that one going to look like? The last one didn't have an x squared. Again, I'd like to have some x and y values, so I'm going to pick a couple things here and there. X and y values. There we go. Should I start the same way as last time? Should I start this? So let's maybe try a -1 and a 0 and a 1, and we'll see what happens. That seems like a good plan. This is going to be nice for simplifying. I like it when the y is by itself. So y equals, our strategy is the same. Instead of y equals x squared, put the number we picked in for x. So we are taking our -1 and squaring it. What is -1 times -1? That happens to be 1. So if I plug in a negative 1, I get a positive 1. Plug in a negative 1, I get a positive 1. All right, let's go with 0. Y equals 0 squared. Again, putting the 0 in place of the x. Well, that's also kind of nice, because 0 times 0 is 0. So 0, 0, the origin, is going to be on our graph right there. So we like that. Let's go with our next one. Y equals 1 squared. 1 squared. Well, 1 times 1 is 1. So if I plug in 1, I get... Wait a minute. 1, 1. 1 to the right, 1 up, that's here. That is not a line. Do you know why it's not a line? Because I have x squared. X squared makes a different shape. I don't know what this shape is really yet, so you know what? I'm going to try to get 2 more numbers in here. I want to see what's happening 1 more to the left here, so I want to find out what's happening at negative 2. And quite frankly, I'd also like to know what's happening at positive 2. So I'm going to squeeze these 2 numbers onto my table just for a little bit more information. Again, what I'm doing with this is I'm trying to find out what shape I'm making here. The negative 2, so just plugging in, negative 2 for x, y equals negative 2 squared. Well, what's negative 2 times negative 2? That's a positive 4. So if I plug in a negative 2 in place of x, I get a positive 4. Negative 2, that's 2 to the left and then 4 up. That's there. Well, that's interesting looking. What happens if I do a positive 2? Y equals positive 2 squared, plugging the positive 2 in for x. 2 times 2 is 4 again. There's some interesting symmetry going on here. What's happening on the left and the right? They mirror each other. What is this? In case you care, this is definitely not a line. It is called a parabola. It is called a parabola. It's different from the last one, yes, but notice the strategy still works. Take your equation, pick some numbers, and plug into the equation. See what happens. If you can make pairs, you can make graphs. Doesn't matter what it looks like. One last one here, okay? One last one. Notice this one here has absolute value in it. So this is also going to be an interesting shape. Let's see what we can do with that, shall we? So let's get our XY table going here. XY. Should we start with the same ones as last time? I think that seems like it's pretty good, doesn't it? So we'll start with our negative 1 and our 0 and our 1. Find out what's happening around the axis here. So again, I'm going to plug into the equation, taking the x out and putting this number in its place. So instead of x plus 1, I'm going to do the absolute value of negative 1 plus 1. Absolute value of negative 1 plus 1. Absolute value equals y. Again, it's kind of nice I've got that y by itself. That makes me happy. What is negative 1 plus 1? 0. Okay, so what is the absolute value of 0? Let's think about that. Absolute value is how far you are away from 0. How far is 0 away from 0? 0? It's right there. It's not any distance at all. So when I plugged in a negative 1, I got a 0. That's the first of my pairs. So negative 1, that's 1 to the left, and 0 means I'm not going up or down. So this point is going to be on my x-axis right there. What happens if I plug in 0? Again, we are doing absolute value here, and we are replacing the x with the 0. So 0 plus 1, the absolute value equals y. 0 plus 1 is 1. So what is the absolute value of 1? Well, how far is 1 away from 0? 1. That's what absolute value is, distance from 0. So when I plugged in a 0 this time, I got a 1. Plugged in a 0, so 0 and then 1, that's on my y-axis right there, 0, 1. So what about positive 1? Let's see here. So we'll go absolute value again, plugging in 1 for x. That's going to be 1 plus 1 in my absolute value signs there. 1 plus 1 is 2. So the absolute value of 2. How far is 2 away from 0? You guessed it, 2. There we go. And so when I plug in a 1, I get a 2. Plug in a 1, I get a 2. This is looking more like the first one. That looks like it's a line, doesn't it? Can you humor me for a second? Just because I know a little bit about what's happening here. I want to plug in a negative 2. I want to see what's happening over here, because I have a hunch. All right, so what happens if I do negative 2? Absolute value of negative 2 plus 1. Absolute value of negative 2 plus 1. Negative 2 plus 1 is negative 1. And so I'm doing the absolute value of negative 1. How far is negative 1 away from 0? 1. So when I plugged in a -2, I got a +1. And that's that absolute value at work. So I plugged in a -2, I got a +1. So it's not like the first one exactly, but it's also not like the second one, because the second one, this has this like 1 over 1 up and then 1 over and 3 up. So there's different patterns happening here. But this one, 1 over 1 up, 1 over 1 up, just kind of keeps going. All right, so tell you what, I'm going to go with just one more. My screen froze for a second. We're back in action. Excellent. So last one, I'm gonna go one more this direction. I'm gonna go with -3. Okay. So absolute value of -3 plus 1. Again, taking the number that we picked and putting it in place of the x. So what is -3 plus 1? That is -2. So we are talking the absolute value of -2. How far is -2 away from the origin? 2. That is a distance of 2. So I plugged in -3, I got 2. Plugged in -3, I got 2. So what is this? This graph with absolute value is kind of a combination of these two. It looks like a parabola, but it has straight line pieces like a line does. So I'm going to grab my ruler, because that's a good thing for making straight lines. But this thing's going to end up looking like a V instead of a U because of the straight line pieces parts of things. So ladies and gentlemen, lines will always look like lines. Anything with x squared, well, as long as it doesn't have any extra craziness part of it, is going to be a parabola. And if you're seeing absolute value, your graph should probably be a V shape of some kind. So with this, patience is everything, my friends, all right? Take your time, plug stuff in, don't be in a rush. You've got this. You can graph anything, I promise you, anything.